All right, welcome to another JNCIE-SP video. Hoping to round out the topic of BGP load balancing using multipath. So last video, I finished the configuration for the second example that we were doing. So this video is going to be the verification and the Wireshark capture. So let's start by having the Wireshark capture going. On router 1, we'll be doing show routes 1.1.1.230.0 extensive. But let's start the Wireshark capture between router 2 and router 3 and just have that sit in the background. The other thing I would like to do is some trace options on router 2. Oops. Oh, and it looks like we've got the classic frozen command line problem. I haven't had this in a long time, thankfully. It looks like it's something that really doesn't happen that much if you kind of have a fresh install of the device. These devices I've been reusing for multiple labs now, so they're starting to get so that they've had probably over 20 commits on them so far, and I'm starting to see this issue now for the first time in a long time. So I'm gonna stop the capture. Unfortunately, this this video was mostly about verification and Wireshark capturing, so I'm not really sure how I can fill the time without having that. But I will certainly make it public how I address this issue, and this is by rebooting all of the routers, which I prefer to do by rebooting the GNS VM. That way I get to, it just seems a little bit faster when I do it that way. So we're going to reboot the VM. And now we'll just need to wait for that to come back up. Connection refused because the server is rebooting. It's not up yet. So this is, the server's at 192.168.1.102. So looks like it's up now. But it's up now, but the GNS VM looks like it's still booting up some like daemons and processes that it needs to run fully. If anyone's, yeah, so GNS3. Looks like it's still booting up. So one thing I can do is the reading for the next load balancing I was planning to do. I was going to do understanding consistent load balancing through resilient hashing on Ecmp groups. I'll just read this. It looks like there's no lab to go along with it. So while that's booting up, I'll just read these two sections. I think it's going to be valuable for me to know about this. So Understanding consistent load balancing through resilient hashing on Ecmp groups, equal cost, multipath. So it's a BGP concept because these are multipath groups. You can use consistent load balancing to minimize flow remapping in an equal cost multipath Ecmp group. By default, when there are multiple equal cost paths to the same destination for the active route, Junos OS uses a hash algorithm to choose one of the next hop addresses to install in the forwarding table. Whenever the set of next hops for a destination changes in any way, Junos OS rechooses the next hop address by using the hash algorithm. You can configure consistent load balancing on the switch to prevent the reordering of all flows to active paths in an Ecmp group when one or more next hop paths fail. Only flows for paths that are inactive are redirected to another active next hop path. Flows mapped to servers that remain active are maintained. This feature applies only to external BGP peers. Configuring consistent load balancing for Ecmp groups, equal cost multipath. Per packet load balancing allows you to spread traffic across multiple equal cost paths. By default, when a failure occurs in one or more paths, the hashing algorithm recalculates the next hop for all paths, typically resulting in the redistribution of all flows. Consistent load balancing enables you to override this behavior so that only flows for links that are inactive are redirected. All existing active flows are maintained without disruption. In a data center environment, the redistribution of all flows when a link fails potentially results in significant traffic loss or a loss of service to servers whose links remain active. Consistent load balancing maintains all active links and instead remaps only those flows affected by one or more link failures. This feature enables that flows connected to links that remain active continue uninterrupted. This feature applies to topologies where members of an equal cost multipath Ecmp group are external BGP neighbors in a single hop BGP session. Consistent load balancing does not apply when you add a new Ecmp path or modify an existing path in any way. To add a new path with minimal disruption, define a new Ecmp group without modifying the existing paths. In this way, clients can be moved to the new group gradually without terminating existing connections. On MX series, only modular port concentrators, MPCs, are supported. Both IPv4 and IPv6 paths are supported. Ecmp groups that are part of virtual routing and forwarding, VRF instance, or other routing instance are also supported. Multicast traffic is not supported. Aggregated interfaces are supported, but consistent load balancing is not supported among members of the link aggregation lag bundle. Traffic from active members of the lag bundle link aggregation might be moved to another active member when one or more member links fail. Flows are rehashed when one or more lag member links fail. We strongly recommend that you apply consistent load balancing to no more than a maximum of 100 IP prefixes per router or switch. Layer 3 adjacency over integrated routing and bridging, IRB, interfaces is supported. You can configure the BGP add path feature to enable replacement of a failed path with a new active path when one or more paths in the Ecmp group fail. Configuring replacement of failed paths ensures that traffic flow on the failed paths are only are redirected. Traffic flow on active paths will remain unaltered. Note, when you configure consistent load balancing on generic routing encapsulation, GRE tunnel interfaces, you must specify the INET addresses of the far end GRE interface so that the layer 3 adjacencies over the GRE tunnel interfaces are installed correctly in the forwarding table. However, Ecmp equal class multipath fast reroute FRR over GRE generic routing encapsulation, I believe. I don't remember. I'm going to look it up. Aha, I was right. Generic routing encapsulation. Tunnel interfaces is not supported during consistent load balancing. You can specify the destination address in the router configured with consistent load balancing at the edit interfaces, interface name, unit name, family INET address, address hierarchy level. For example, destination right there. And this is a tunnel interface, a GRE tunnel. And then here's the address of the tunnel interface and then the address of the other side of the tunnel. You need to specify both when you configure a tunnel. For more information on generic routing encapsulation, see configuring generic routing encapsulation tunneling. Consistent load balancing does not support BGP multi-hop for eBGP neighbors. Therefore, do not enable the multi-hop option on devices configured with consistent load balancing. To configure consistent load balancing for Ecmp groups, configure BGP and enable the BGP group of external peers to use multiple paths. Create a routing policy to match incoming routes to one or more destination prefixes. So let's, hopefully the lab is up now. It is. Yep. So everything looks good to go. They might still be waking up, unfortunately. Nope, they're already awake. So yeah, that was pretty fast. All right, and let's just kind of do that on the command line without committing anything. All right, so let's do the GRE as well. So we're going to do set, oops, we're going to do edit interfaces GR 400 unit 21 family INET address 10.10.31.2/32. Destination. Oh, it looks like no valid completion. So this is not something I can do, unfortunately. So yeah, it looks like I won't be able to follow along with this example. Good to know. But let's try the next example. So it's going to be under policy options. All right, so now to apply consistent load balancing to the routing policy so that traffic flows to one or more destination prefixes that experience a link failure are directed to an active link. And we'll do a commit check on this. So the check succeeds. Create a separate routing policy to enable per packet load balancing. You must configure and apply a per packet load balancing policy to install all routes in the forwarding table. Apply the routing policy for consistent load balancing to the BGP group of external peers. Consistent load balancing can be applied only to BGP external peers. This policy cannot be applied globally. Optional, enable bidirectional forwarding detection, BFD, for each external BGP neighbor. All right, next step shows the minimum BFD. This step shows the minimum BFD configuration required. You can configure additional options for BFD. Apply the per prefix load balancing policy globally to install all next hop routes in the forwarding table. Optional, enable fast reroute for Ecmp routes. Verify the status of one or more Ecmp routes for which you enabled consistent load balancing. The output of the command displays the following flag when consistent load balancing is enabled: state, active, ext, local, val, consistent hash. All right, so that's enough of the reading for that. So let's move on to the verification steps now that the lab is back up. So starting on router 1, show route 1.1.230.0 extensive. Okay, so everything looks pretty good. We've got a path. We've got vector length 4, value. We've got 0. They've got 1. So I'm not sure what that's all about. We've got our advertised metrics. So it looks quite a bit different from what they've got. Maybe they put on a, yeah, we put on